Hello everyone and welcome to Learn at the Rate 10. Today we are going to learn to find roots of quadratic equations. Now if you have not watched my previous video, Introduction to Quadratic Equations, I would advise you to do so before starting with this one. Now roots are nothing but answers to quadratic equation, where we find numbers specific to a variable. The first of this method is factorization method. Here we have a quadratic equation from which we find linear factors. This linear factors helps us to find our roots. Let us solve our first sum. X square minus 15x plus 54 is equal to 0. Here the equation is in the form of ax square plus bx plus c is equal to 0. We can have two conditions. When a is equal to 1 or a is not equal to 1. Here in this method a is equal to 1. This sum can be solved by the steps. When a is equal to 1, we will find two factors of the third term, which is 54, in such a way that when we add those two numbers or two factors, we will get a sum which is equal to the middle term, which is minus 15. Now, as you can see, there are multiple factors of 54. 2 into 27, 3 into 18, and 6 into 9. Now, when I take 6 into 9 and I take minus 6 minus 9, I get a sum of minus 15. Therefore, minus 6 and minus 9 becomes my factors. So, I will split the middle term in these two factors and I will get x square minus 6x minus 9x plus 54 is equal to 0. Now I have to take out the common between x square minus 6x and common between minus 9x plus 54. To do so, from the first set I will take out x, which is common in x square minus 69. Therefore x into x minus 6, which is the remaining term, minus 9 comes out as common from the second group and gives me x minus 6 in the bracket is equal to 0. One pro tip to find out whether you are on the right path, always look at the numbers inside the brackets. If the terms inside the bracket are same, then you are on the right path. Now we will write the terms outside the brackets together in one bracket, which gives me x minus 9 into the second term, which will be a common one from the brackets. Here it is x minus 6 is equal to 0. Now if two of our factors are giving product is equal to 0, that means one of them has to be 0. Therefore either x minus 9 is equal to 0 or x minus 6 is equal to 0, which gives me x is equal to 9 or x is equal to 6. Therefore 9, 6 are the roots of the given quadratic equation.
Now let us solve a sum where a is not equal to 1. Then what? Let's take this sum. 2y square plus 27y plus 13 is equal to 0. While comparing this with the general form of quadratic equation ax square plus bx plus c is equal to 0, we notice that a here is equal to 2. In such situation where a is any other number than 1, we will multiply the first term with the last term. Therefore, 2 into 13 is equal to 26. Now we have to find factors of 26 such that their sum is 27. Note here that we will not take factors of the last term 13, but the product of the first and the last term, which is 26. It is very simple, since 26 into 1 will give me 26, and adding 26 and 1 I will get 27. I will split the middle term in these two factors. Therefore 2y square plus 26y plus y plus 13 is equal to 0. Notice, instead of writing 1y, I have written just y. I have to take 2y, which is common in the first group, is taken out, and in the brackets it's y plus 13 plus 1, which is common in the second group, gives me y plus 13 in the bracket is equal to 0. Notice that both the brackets are same. Therefore, I'm on the right path. Therefore, 2y plus 1 into y plus 13 is equal to 0. Product of two of my factors is equal to 0 means that one of the factors has to be 0. Therefore 2y plus 1 is equal to 0 or y plus 13 is equal to 0. This gives me 2y is equal to minus 1 or y is equal to minus 13. Solving this, I get y is equal to minus 1 by 2 or y is equal to minus 13. Therefore, minus 1 upon 2 comma minus 13 are the roots of the given quadratic equation.
Now let's take a different type of sum. In this sum, we have numbers in under root and numbers which are not perfect squares. Most of the people get confused when there are numbers involving under roots of imperfect squares. Let's take this example. 3x square minus 2 into under root of minus 6x plus 2 is equal to 0. Now how to solve root? Remember, if you have under root of a number which is not a perfect square, then you can always split it into two factors, out of which one of them would be a perfect square and the other one would be an imperfect square. Let's take an example of under root of minus 12, which can be split into under root of 3 into 4. Now 4 is a perfect square, therefore I can take square root of 4 and it will give me 2 under root 3. Also, there might be accounts where you have numbers like 2 into under root of 3, which is multiplied by another under root 3. In such case, under root 3's get multiplied and we get a complete 3. This 3 is then multiplied by 2 and we get the answer as 6. Remember, whenever an under root is multiplied by itself, we get a number without the root. Under root of 3 into under root of 3 will give me 3 as whole. Now using this information, let's try to solve this sum. Here, let's compare the quadratic equation with the general form ax square plus bx plus c is equal to 0. Now in this sum, as we know that a is not equal to 1, therefore I have to multiply the first term with the last term, which gives me 3 into 2 is equal to 6. I have to find factors of 6 such that when I add them, I get a sum as middle term, which is minus 2 into under root of 6. I know that if I multiply minus of under root 6 with minus of under root 6, I will get 6. And when I add minus 6 plus minus 6, I will get minus 2 root 6. Therefore, I will use these two and split the middle term in the equation, which gives me 3x square minus under root of 6x minus under root of 6x plus 2 is equal to 0. Now I have to find common factor between 3x square minus under root of 6. To find common factors, I will have to split the number 3 in its under root forms. Therefore, 3 can be factorized as under root 3 into under root 3 and minus under root 6 can be factorized as under root 3 into under root 2. Therefore, from 3x square minus under root of 6x, I get under root of 3x as common, and in brackets under root 3x minus under root 2. Now from the second group, minus under root 6x plus 2, I have to split 2 into its under root forms, which is under root 2 into under root 2 and under root 6 in its factors as under root 3 into under root 2. From these four, I will get under root of 2 as my common, which will come out of the bracket, and inside the bracket I will get under root 3x minus under root 2 is equal to 0. I will unite the terms which are outside the bracket and make a bracket, which is under root of 3 minus under root 2 multiplied by a single term which is inside bracket, under root 3x minus under root 2 is equal to 0. Therefore, under root 3x minus under root 2 is equal to 0, or under root 3x minus under root 2 is equal to 0. This gives me x is equal to under root 2 upon under root 3, or x is equal to under root 2 upon under root 3. Did you notice that the roots here are equal? We will talk more about equal roots in the following videos. Therefore, under root 2 upon under root 3, comma, under root 2 upon under root 3 are the roots of the given quadratic equation. Similar types of sums can be solved in the textbook of Maharashtra State Board. Please check the description of this video to find similar sums which you can solve based on these concepts. I hope you enjoy concept-based learning, and if you have any doubts or queries or you want to give any suggestions, I would be happy to receive so. Thank you.